Hey guys, welcome back. Today we are going to solve a problem from CPM, Pert CPM problem, which is from June 2024 problem. Okay, the concept why we are working out this kind of problem is we want to save the cost by reducing the time we are spending for the project. For example, if you are building an if we are building an house, no, to build this house we have to lay the foundation, then we have to raise the walls of side, and we have to start a work like this, and then we have to put a ceiling, and then we have to put a roof. So all these things are simultaneously, all this not simultaneously happening, it's all one by one, one by one, it's all happening, no. So when the work, when in any, if any project is depending on the previous project, no, immediate predecessor only complete. When the immediate predecessor completes, only the next activity will start, no, at that time. What we have to do, no, we have to check the most efficient ways to reduce the timing and the cost. So that's what we are using the time. So this will helps us reduce the cost by finding the efficient ways to reduce the cost rates. Okay, that's what we are preparing the critical path method. Okay, right. What in the question they have said is Zotec Limited. Okay, recently won a contract for installation of die casting machines. Okay, they are installing the die casting machine at the local factory of a large national firm of electronic engineering. Okay, the following table gives the various activities in the job and a normal duration. Okay, these are all the type of activities they have while they are installing the machinery. Okay, and the preceding activity. See, once the A once A and B completes, no. See, once A completes, B starts. So this is a based on the predecessor. The next activities are depending on. Okay, so next activity start times are depending on. So the duration also given. For A it takes 2 days. For B it takes 3 days. For C it takes 15 days. Like this, it's going on. Okay. See, and then what they have asked us to find the design the port CPM network diagram and indicate all paths to it. Okay, then they asked us to find out the critical path method, where the critical path means where the project is taking more time. So that area we have to find out. Okay, and what's the duration for that period, and we have to assess the total float, tree float, and independent float, that, right? Okay, first let's build the critical path method. Okay, first activity 1. A. A. A starts with 1 and ends with 2. See, 1, 2. Okay. And 2 starts with 1, 3. There is 3, 4. And then it goes to 5 also. Right. All these activities are B, C, D. What I have done is 2 to 3 they have said, so I have created line. 2 to 4 I have created line. 2 to 5 I have created a line. Then what they have said is 3 to 5, which is C, where the B ends, E starts. B ends here. E should start from here. Okay, E. Then, but you can see that E is also a predecessor of G. D is also a predecessor of G. F is also a predecessor of G. Okay, so what we have to do is we just build the line for F, and then, okay, this is not E, this is 5, and this is not F, which is 3 to 5 is E, 4 to 5 is F, and then D, E, F. All those lines are connected with 5. Okay, so what we have to do is we just bring down this 5 now, little below. Okay, F, E, then D. Right, from 5 G activities start. G activity started. After G, H activity started, right? So that's it. The chart is over. So we have done it. Then we have to allocate the duration for this activities. For A it is 2, for B it is 3, for C it is 15, for D it is 3, for E it is B, for sorry for E it is 12, for F it is 8, for G it is 3, for H it is 12, right? So we have filled the duration also. So after that, what we have to do is we have to fill the yearly start time and yearly finish time, latest finish time. Every activity boxes, no, it will have the yearly start time and yearly finish time, the latest finish time. Okay, let's quickly put the boxes. Right? Yes. Okay, the top box denotes the latest finish time, and bottom box denotes the earliest finish time. This applies to all the boxes, right? So what's the earliest start time? Earliest start time is always 0. Earliest start time is always 0. 0 plus 2, the activity duration 2. 2 plus 3 for B's activity duration, which totals to 5. Then 2 plus 15, 17. Then 2 plus 3, which is, okay, there is a 3 paths are no, 3 paths are reaching one location, so we have to take the maximum when we are going on a forward direction. Okay, when we are in a backward direction, we have to take the minimum value, right? Okay, 17. And then there are three lines are coming. So 12, 5 plus 12, which is 17. 17 plus 8, which is 25. 2 plus 3, which is 5. So we have to take the 25. Okay, so 25 we have taken. Then 25 plus 3 is 28. 28 plus 12 is 40. Just copy paste the earliest start time in the 7th node, no. So copy the same thing on the top itself also. So from here, what we have to do is we are we are going in the backward direction. Deduct the amount, which is 40 minus 12, which is 28, and then 28 minus 3, which is 25. From here we have to go to 3, which is 25 minus 12, which is 13. 25 minus 8, which is 17. 25 minus 3, which is okay, here you can see 3 lines are reaching the one boxes, so we have to take the minimum balance, no. So which has the minimum balance? 5 plus 3, which is 8. Then 17 plus 15, which is sorry, difference we have to find now. 5 minus 3, which is 2. Sorry, 13 minus 3, which is 10. 17 minus 15, which is 2. And then 25, which is 22, right, which is the lowest minimum value, which is 2. So to take the 2 here, right, and then 2 minus 2, which is 0. So we have found the latest finish time and and the earliest start time of all the nodes. You can check. You have to draw the line where both the LFT and EST are same. See, here it is same. In this path 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 it is same. So from 1 to 2 to 4 to 5 to 6, sorry, 5 to 6 to 7. So what's the duration? 2 plus 15 plus 8 plus 3 plus 12. How much is the total duration? 40 is the total duration. See, it's actually same with the final node. Okay, we found this is the actual critical path. No, this is where the time is taking more long, right? Then we have found the we have figured the Pert diagram, and also we have done the critical path and the total duration in days. So it's taking a 40 days duration. Now what we have to do is we have to find out the total float, free float, and the independent float. Okay, to find out the total float, free float, and final float, independent float, we need to know the total float formula and the free float formula and independent float formula. Okay, we are going to find out the formula for total float. Okay, total float formula is latest finish time 2 minus yearly start time 1 minus duration of 1 2. Okay, which is the latest finish time? This is the latest finish time. We are comparing, we are going to find the difference with earliest start time, and then this is the duration 1 2. Okay, this is what that. Then the free float is earliest start time 2 minus earliest start time 1 minus d12, which is earliest start time 2. This is 2, this is 1, this is 2, and then we are finding with the this is 1 2. So we are finding the difference of earliest start time 2 minus earliest start time 1 minus duration. Okay, then the independent float. What the independent float formula is? This is exactly this line. We are going to compare the earliest start time of 2 minus latest finish time of 1 minus d12. Sorry, this is earliest start time 2 minus latest finish time 1 minus d12. Guys, here you can understand that what are all the values we need here. We need to arrange in a table LFT. See, LFT1, LFT1, LFT2, LFT1, LFT2, then EST1, EST2, then D12. That's it. These are all items we are going to fill in a table now. Okay, just put a total activity duration, EST1, EST2, LFT1, LFT2, free float, sorry, total float, free float, independent float, right? So that's it. See, activity 1 A to H. See, duration 2 3 15 3, twelve 8 3 12. Then EST1 of let's fill the identification number also, that will help us. 1 to 2, B is 2 to 3, C is 2 to 4, 2 to 5, E 3 to 5, 4 to 5, 5 to 6, 6 to 7. Right. Okay, EST1 for the activity 1 2 is 0, and then est2 is 2, right? lft1 is 0, lft2 is 2. For 2 3, for b2 3, b2 3, no. Okay, the est1 is 2, est2 is 5, lft1 is 2, lft2 is 13. Same like C 2 to 4, which is EFT1 is 2, EST2 is 17, LFT1 is 2, LFT 2 is 17, right? Same goes for 2 to 5, which is EST is 2, EST1 is 2, EST2 is 25, C2 is 25, LFT1 is 2, LFT2 is 25. Then E, which is 5 25 13 25. See, 5 25 13 25. Then for F, 17 25 17 25. For G, 25 28 25 28. For H, 28 40 28 40. Right, what's the total float formula? LFT minus EST1 minus D12. These are all the three things we have to do. 2 minus 0 minus 2, which is 0. Then 13 minus 2 minus 3, which is 8. Then 17 minus 2 minus 15, which is 0. Then 25 minus 2 minus 3, which is 20. Then 25 minus 5 minus 12, which is 8. Then 25 minus 17 minus 8, which is 0. Then 28 minus 25 minus 3, which is 0. Then 40 minus 28 minus 12, which is 0. Okay, so we found the total float. What's the free float? Free float is EST2 1, EST2 2, D1 to 3 is 3. Okay, so 2 minus 2 minus 0 minus 0. Then 5 minus 2 minus 3, which is 0. Then 17 minus 2 minus 15, which is 0. Then 25 minus 2 minus 3, which is 20. Then 25 minus 5 minus 12, which is 8. Then 25 minus 17 minus 8, which is 0. Then 28 minus 25 minus 3, which is 0. Then 14 minus 28 minus 12, which is 0. What's the formula for independent float? EST minus LFT and LFT minus D1T. So 2 minus 0 minus 2, which is 0. Then 5 minus 5 minus 5 minus 2 minus 3, which is 0. Then 17 minus 2 minus 15, which is 0. Then 3 minus 25 minus 2 minus 3, which is 20. Then 25 minus 13 minus 12, which is 0. Then 25 minus 17 minus 8, which is 0. Then 28 minus 25 minus 3, 0. Then 28 minus 25 minus 3, which is 0. Wait. 40 minus 28 minus 12, this is also 0. Okay. Guys, you can see that wherever all the zeros are equal, no, this is our actual critical path, which is 1 to 2, no, 1 to 2, 2 to 4, 4 to 5, 5 to 6, 6 to 7. So we have finished the problem. That's it. Thank you.